All right, this is AP, AB, and BC Calculus. We are doing Unit 4, Section 6, which is approximating the values of a function using local linearity and linearization, which is essentially using tangent lines. So we can use the tangent line of a function at the point x equals a to approximate values of the function very close to x equals a. So generally, the closer the x value is to a, the better the approximation. So to use a tangent line, we'll first have to find the equation of a tangent line, which we've done previously, but we'll also review here. And then once we have the equation, we can plug in the x value to find an approximation for the function value. We'll also learn how the curve's behavior around the point of tangency can tell you if the approximation is over or under the actual value. So let's go ahead and dig in. We'll do that towards the end of this video. So write the equation for the tangent line to f of x at x equals 4. Use your tangent line to approximate 4.1. So in order to write the equation of a line, I need two things. First thing I need is a point, right? I was given half of the point. I was given 4, comma blank. So to find that blank, I'm going to do f of 4, which is an algebra skill, right? That's going to be 4 squared, so 16, minus 3 times 4, which is 12, plus a 2. So I get 4 plus 2, which is a 6. So my point is 4, comma 6. So then the second thing I'm going to need is a slope, right? And that slope is going to be a calculus skill, right? So that slope, my tangent slope, I'm going to call it m sub t, is going to be f prime of 4, which means I need to find f prime first. So my f prime of x is going to be a 2x minus 3, which means that f prime of 4 is going to be an 8 minus 3 or a 5. So now I need the equation of that line. So my equation is going to be y minus the y value equals my m, and then in parentheses, x minus the x value. Most of the time, the easiest way to deal with this, don't clean it up a lot, leave the 5 undistributed, but add the 6 to the end on the other side. So there's my tangent line. Now, we want to be really clear with our mathematical language. If we're going to approximate f of 4.1, we need to make sure that we say f of 4.1 is approximately, and then I'm going to plug in here. Now here you'll notice the benefit of not distributing, because notice that when I do 4.1 minus 4, I'm going to get a 0.1, which is some easy mental math. So I'm going to get 5 times a 0.1 plus a 6. I'm going to get that f of 4.1 is approximately a 6.5. Now, if you had distributed and cleaned up, it's actually going to make your math a lot harder when you use your tangent line approximation. So that's kind of the gist. Let's go to a P1. Same deal. You're asked to find the tangent line to g of x at x equals -1, and then use the tangent line to approximate a value. So first thing I need is a point, right? To find that point, I have -1, comma, and then I'm going to find g of -1, right? So g of -1 should be a -1 plus a 5 plus a 2 plus a 3, right? Which I'm pretty sure comes out to be a 9. Right? Second thing I'm going to need is a slope, right? My tangent slope is going to be g prime of -1, so I need to find g prime real quick. So g prime of x is going to be a 3x squared plus a 10x minus a 2, which means that g prime of -1 is going to be a 3 minus a 10 minus a 2, which seems to be a -9. So my equation is going to be y minus the y value equals my slope, and then in parentheses, x minus the x value. So when I add that 9 over, I get -9, and then in parentheses, x plus 1, all plus a 9. That's the equation I want to use, right? That's the first thing I was asked to do. The second thing I was asked to do was to take that equation and approximate g of -1.2, right? Make sure that you communicate that that's what you're doing, right? And make sure you use the approximately symbol. So -9. Now when I plug in a -1.2 plus that 1, again, it's going to be easy mental math, right? This is going to be a -9 times a -0.2 plus 9. Well, that's a 1.8 plus 9, which means that my g of -1.2 is approximately a 10.8. All right, moving on. Okay, so this time I don't have an equation, but I have other stuff that I need. So I'm asked to use the equation to the tangent line at x equals -2 for this f of x function. Well, I need two things. I need a point. Well, I was given the point, right? I was given the point that when I plug in -2, the output is a 3. And the second thing I need is a slope, but I was also given the slope. I was given that my tangent slope, which should be f prime of -2, is a 7. So I was actually given everything I need in this problem to just jump to the equation. Y minus the y value equals my m, x minus the x value. Y equals 7, and then in parentheses, x plus 2, subtract that 3 over. This is my tangent line, right? And then I'm asked to use that tangent line to approximate this value. So I want to articulate clearly that that's what I'm doing, right? I want to say that this is the thing I'm approximating. And when I plug that in, I'm going to get 7 times a 0.1, right? Because negative 1.9 plus 2 is a 0.1, minus a 3, right? That's a 0.7 minus a 3, which seems to be a negative 2.3. Right? And again, I'm clearly using the approximately symbol. I'm making it clear that what I'm finding and what I'm approximating is f of negative 1.9. All right, moving on to the next one. Same idea, but you're doing it with g, right? So, again, I have a point, right? That's my point. And I have a slope because I was given g prime of 5. So my slope is that m tangent is g prime of 5, which was a -4. So that means I have an equation. If you're able to do both of those things in your head and jump to here, nobody thinks you're cheating. That's great, right? So y minus the y value equals my slope, which is -4, x minus the x value. I would add the 6 over to make my calculations easier, right? So this is the tangent line that I'm going to use. And then when I use it to approximate g of 5.3, right? So g of 5.3 is approximately, and then I just plug a 5.3 in here. So that's a -4 times a 0.3, because it's 5.3 minus 5, plus a 6. Well, that is a -1.2 plus a 6, which means I'm pretty sure we get a 4.8. All right, moving on. Okay, so same idea, presented with a lot of information in a table, but it's not a more difficult problem. So we're given values of f and f prime. We are asked to use this to make the best tangent line approximation for 3.1, right? So f of 3.1. Well, that means we're going to use this. Why this? Because x equals 3 is the one that is the closest to x equals 3.1. So the trick here is you were given other information and it's useless, right? So in this situation, I'm going to use the point 3, 6, and I'm going to use the slope that f prime of 3 is a 4. That's a prime. It just kind of got swallowed by the letter p, so that's my tangent slope. So it seems to me that the equation I'm going to use is y minus the y value equals my m, which is 4, x minus the x value. So my equation is y equals 4 times the quantity x minus 3 plus a 6. Now I'm going to use it and say that f of 3.1 is approximately a 4 times a 0.1, because that's what 3.1 minus 3 would be, plus a 6. So I get approximately a 6.4. Right? So this is one of the classic things the AP will do. They'll give you way more information than you need to try and throw you off the scent. The only piece you needed here was x equals 3. For P3, we're approximating g of 9.8, which means this is the information that I need, right? Because x equals 10 is the one that is the closest to x equals 9.8, right? So what's going to happen is we're going to take my point, which is my point is going to be 10 comma -6. We're going to take my slope, which is going to be g prime of 10, which is 7. Right, so my slope is 7. And so my equation is going to look like this. Y minus the y value equals the 7 and then x minus the 10 in parentheses. So when I subtract that 7 over, I'm going to get, or sorry, that 6 over rather, I'm going to get 7x minus 10 in parentheses minus a 6, right? So this is what I'm going to use when I'm asked to approximate g of 9.8. G of 9.8 is going to be approximately 7 times, this will be a -0.2 minus a 6. So that's a -1.4 minus a 6. I get that g of 9.8 is approximately -7.4. All right. So In Unit 5, we're going to learn how to find concavity of a graph mathematically, but for now, we're going to use our eyeballs, aka by visual inspection. A graph is concave up at the point of tangency. Concave up means cupping up, right? So like if you're cupping upward, right? So concave up looks like cupping this way, right? So if a graph is concave up, as you can see here, what you'll notice is that the tangent line is physically under the curve. See how this is, so at this point of tangency, see how this graph is cupping upward, and you see how the blue line is under the curve. So if you're told the concavity of a function, right, if you're told what the concavity of a function is, then you can determine if the estimate using the tangent line is under or over. So if I were to use this tangent line to estimate this curve, any estimate I get will be physically lower because that line runs under the cup. The cup is cupping upward, the line is fitting under the cup, okay? By the same token, if I have a graph that is concave down, so this is a graph that is cupping downward, right? This is what cupping downward looks like, right? It looks like this or like this, right? Cupping down doesn't have to be a full cup. It can be half of the cup or half of the cup this way or the full cup, but it's cupping downward, just like cupping up could be the full cup like this, or it could be just this half, or it could be just this half, but those are all cupping upwards. So notice that if something's cupping downwards, then the line physically sits on top of that, meaning that any tangent line you use to approximate it will be an overestimate. So if you're asked if a tangent line approximation is an over or underestimate, it's a question about the concavity of the graph. Again, in Unit 5, we're going to talk about how to mathematically find those values, but for right now, we're just going to be able to assess visually if a graph is cupping up or cupping down. So let's look at this one. All right, so the graph of the function f of x is provided here. Select table of values of f prime are provided. A, write the equation of a tangent line at x equals 1. So we have the point already, right? So that's my point, right? And at x equals 1, my slope is a -1, right? So my tangent slope is -1. So the equation of the curve is going to be y minus the y value equals my m, x minus the x value. I'm going to subtract that 2 over, and I'm going to get y equals -1, the quantity x minus 1, all minus a 2. Right, so that's my part A. Next, I'm asked to use that to approximate 0.8, so f of 0.8 rather. So f of 0.8 is approximately -1 times a -0.2 minus a 2, right? Well, that's going to be a 0.2 minus 2, which is going to be a -1.8, right? So that's my approximate value. And then I'm asked, is this an over or under estimate? Well, if you look at this curve is cupping upward, which means that any tangent line you draw is going to be physically below it. So because f of x is concave up at x equals 1, it's an underestimate because you can see that the blue line that I drew, the tangent line, falls under that cupping upward, right? So any value I pick on that tangent line will be physically below the curve. And you need to include the concavity in your explanation. On the AP, they're going to ask you to justify your answer by including the concavity. All right, so let's do another one like that. So here's this function. We're talking about the 0.22, right? That's my point. And since I'm talking about the 0.22, this is going to be my slope, right? My tangent slope is going to be -22. So first, write the equation for the tangent line. Well, that's going to be y minus the y value equals my m, x minus the x value. So I'm going to add the 2 over and get y equals -22, x minus 2 in parentheses, and then add a 2, right? So that's my answer. Now I'm going to use that to approximate g of 2.1. Well, that's going to be approximately -22 times a 0.1 plus a 2. Well, that is a -2.2 plus 2, so that's a -0.2, right? So, these are all equal, but this first step has to say approximate because that's not the value of g. Lastly, is this an over or underestimate? Well, if you look at the way this curve is cupping, see how this is cupping down, right? So because g of x is concave down at x equals 2, it's an overestimate. Right? And you can see that if we take a second and draw, so if you draw a tangent line, see how the tangent line would sit physically above the curve? I'm doing a terrible job of drawing it, but the idea is that if something's cupping downward, the tangent line is above it, right? Okay, and again, you have to use the concavity to explain that. Okay, so let f of 1 equal 10, and let f of x be a solution to this differential equation, meaning that this is the derivative. So this is the derivative of f of x, right? We're asked to write an equation for the tangent line. Well, we already know half of our answer, right? I already have a point. The point that I have is 1, 10. In order to find the slope, right, my slope is going to be dy dx, which is this expression, so dy dx, and the way we write this is we write this long bar and put a 1, 10. I didn't mean 0 over here, I meant a 10, my bad. And then I'm going to evaluate those numbers. So that's going to be a 3 plus 5, because I'm plugging 1 in for x, over a 10 minus 8. So I should get 8 over 2, which is 4. So my slope is a 4. So y minus the y value equals my slope, and then x minus the x value. I would suggest that you add the 10 over to make your life easier later. So there we have that, right? And then I'm asked to use that to approximate f of 1.3. Well, f of 1.3 is going to be approximately 4 times a 0.3, because that's what happens when I do 1.3 minus the 1, plus a 10. That's a 1.2 plus 10, so I get that f of 1.3 is approximately an 11.2. All right. Same thing here. I have a point already, right? So my point is negative 2, 3, right? Negative 2, 3. My slope is going to be what happens when I evaluate this, right? So when I evaluate dy dx at the given point, which was negative 2, 3. So that's going to be a 4 minus a 10 plus 4 when I plug the x's in. And on the bottom, I'm going to get a 6 minus 4. So it seems to me that on the top I get negative 2, and on the bottom I get 2, so I get a negative 1. So y minus the y value equals my m, x minus the x value. I'll add the 3 over to make my life easier. So it's going to look like this. Then I'm using that value to approximate g of negative 2.2. So that's going to be negative 1 times a negative 0.2 plus 3, which is a 0.2 plus 3. G of negative 2.2 is approximately a 3.2. All right. Okay, so for example 6, we're given that f of 1 is 3, f prime of 1 is 7, and that f of x is concave down on the entire interval right around that point. Okay, so first we're asked to use the equation of a tangent line. Now notice this question is tricky. Sorry, the pen didn't start working. Yeah, there we go. It's tricky because they say use the equation of the tangent line, but they don't actually ask you for the equation of the tangent line. So it's implied that you have to find it in order to do this problem. So we know a point, we know a slope, right? So this is my slope, and my point is 1, 3. So my tangent line is going to be y minus the y value equals m, which is the 7, x minus the x value. I'm going to go ahead and add the 3 over to make my own life easier, right? So this is the tangent line that I'm asked to use but never asked to find. So when I use it, f of 0.8 is going to be approximately 7 times a negative 0.2, right, because 0.8 minus 1, plus a 3. So that's, and again, notice you need the approximate here, but you can say equals for all the others because they are equal. Negative 1.4 plus 3, so I'm going to get that this is a 1.6. F of 0.8 is approximately a 1.6. The question is it an over or underestimate, right? Well, so we know that the graph is concave down, right? So if you picture that, a tangent line is going to be an overestimate. So since f of x is concave down around the spot where x is 1, it's an overestimate. And I'm not lying when I say to you that I have had to draw this picture every time I ever use this justification for my brain. Like, I just know I'll say the wrong thing if I'm not paying attention. All right, last one for this video. Same exact problem. So you're given g of 5 and g prime of 5, right? You are given that the graph is concave up on a particular interval. You are asked to use the equation of the tangent line to approximate a value and then answer whether it's over or under. So here's your slope. Here's your point, 5, 2. The first thing you have to do is write the equation. So y minus the y value equals your m, x minus the x value. I would probably suggest that you add the 2 over to make your own life easier, right? So this is the equation that I'm going to have to use. So my g of 5.3 is approximately -4 times a 0.3 plus a 2, right? That's a negative, that's a 0.3 by the way, that's a negative 1.2 plus a 2, right? Which is a 0.8. So once I know that g of 5.3 is approximately a 0.8, that's my first answer. Then I'm asked, is it over or under? Well, I'm told that the graph is concave up, so that looks like this. Draw a tangent line, you can see that it lives underneath, right? Those values would be under. So since g of x is concave up on this interval, g of 5, 0.8 is an underestimate, right? So 0.8 is an underestimate. You can see that because this is the, like, whatever these are, they are the actual, this is the underestimate, right? So is an underestimate for this. And that is this section.